Okay, now to understand the extra top, so there might be cases where you don't need the extra top, because if the design, the structural design doesn't say that there should be any extra tops, then there should not be any extra tops. For example, the image we saw here, there were no extra tops, right? That's why I draw some over here. So there were no extra tops because the design did not require any extra tops. So the moments that were coming over here, the negative moments that were so negligible that the extra tops were not required. Okay. Alright, now I said that we'll talk about this distance. So this distance is actually L by 4. So what is going to be the L? The L is going to be, we're going to use this measurement right now. The L is going to be from here to here. This is called the waistline. Okay, so it's 9 feet and 9 inches. So if we convert 9 inches to feet, so we're gonna have 0.75 feet. So 9.75 feet, 9.75 feet, 9.75 divided by 4, which is L by 4. L is 9.75 in this case. So we'll get 2.43. So 2.43 feet. So 2.43 feet is not a very good figure, right? If you say, if you ask someone to do, hey, you're going to do an extra top for 2.43 feet, so they're just going to get mad at you, because that is a really tedious work. You're going to need very detailed measurement tools to do that kind of detailing, and the workers are not going to work that hard, and no one actually does this kind of accurate detailing as well. So what that trick here is 2.5 feet are also going to be tricky. So what we did was we actually increased the size a little bit, and I put in here the 3 feet right over there. Okay, so this is the 3 feet. I just increased it a little bit in size. The same thing, the same logic that we had applied for the slab detailings. If you remember that we did not offset from the center lines, instead we did the offset from this edge of the beam, and I explained why we did it from there. The same explanation actually goes for this increased value in length. Instead of 2.44, we have 2.43. I just give it a 3 feet, and someone even does a 3.6 3 feet and 6 inches as well. And you can even go for 2 feet and 6 inches as well, right? Because the accurate measurement was 2.44 feet. Okay. Alright, so yeah, that was it for this video, and with that we have covered the rebars of a stair as well. Here's the 0, we have covered this, 0, we have covered this, we covered this, and let's see what is here for 12mm dia bar, 4-inch center to center. This is the top bar. There is no need to explain it unless the spacing changed there. That's why it was mentioned here. The spacing here actually changed. It changed to 12mm dia and 4-inch center to center. At the bottom it was 12mm dia and then 6 inches center to center. Okay. Right, after that we have A and B here. We get this bar, this is A and B bar, and this is measurement right over here, given there. Okay, and this A plus B 12mm diameter at 6 inch center to center, it was given because someone did not understand the 0 inches note. This note was not understood, so we gave that A plus B, meaning A and B are placed together parallelly, and then between one AB to another AB, the distance is 6 inches center to center. This is just given out there because someone did not understand the note. Okay. Alright, and then here at the length, a length has been given here. The length, you can see that it is the length for this extra top right over here, this extra top, this 110mm diameter extra top in inch gap, this one. So the length right over here is not specified that much, but this length was specified to be this much. So what happens here is actually that if one dimension is given here, that means that this one must also be identical to this dimension. That is why it is not given here. Okay. Alright, so yeah, that was it for this video. Thank you very much for watching. I hope you got to learn something new.